Alright, as promised, I'm going to show you protocols so that we can complete, because we need to get through categories and protocols this weekend. So this is the last new stuff for you. And then we can see what happens after that. So protocols is a part of the code 3. So it's in the code example number 3. So if you're on the website, if you're on the bhacker.com website, here it is. And if you come up here to the Objective-C programming class and you go into source code examples, this is practice number 3. And I'm going to show you practice number 4 next, but that one is not anything new. It's just going to help you with your Objective-C syntax. So practice number 3, I showed you inheritance number 1 and inheritance number 2. And we stopped there and we went to categories. And then now we're going to protocols. So this one we're not going to build, because I don't think anyone has that much energy left, but and whether or not you want to build another project is a totally another story. So instead we'll just take one that's already built and we'll take a look at it. How's that? So, if we wanted to add a protocol to the project, we can still do that. If we go File, New, File, what I did is I opened up the protocol project. And I'm going to add yet another protocol. And I'm going to say File, New, File. And now I'm going to click on Objective-C Protocol. And I'm going to click on Next. You don't actually have to do this. Don't do this. I already have it in here. We don't have to do this. But I'm just doing this to show you how to do it. A protocol looks different. A protocol here I'm going to do, and I'm going to type in testing. I'll just call it testing. And then I press Next, and I'm going to save it into the protocols, and I say, OK, create. Now I have this thing called testing.h. And testing.h is a protocol for NS objects. So I look at this and I see at protocol, and then I see the name, and then I see NS object. The light bulb's gonna click on in a few seconds in terms of what this actually is. Let's take a look at a protocol here called printing. Printing is a protocol, and the protocol has one method in it. And this is printing.h. So if I don't have a .m, what does this remind you of? Starts with an I. It gets implemented in Java. Interface. Protocols are interfaces. They're extra .h files we keep hanging around. If we abide by the protocol, we implement the interface. So take everything about protocols, throw it out the window. It's an interface, but it's not called an interface, it's called protocol. What is protocol short for? Rules. What is rule? What's a rule? Well, we can tag an object with a set of rules that it's required to perform, which is all we're doing with a protocol. So this protocol is called printing.h. We don't get a .m, we just get a .h. So we fill it out. Here's the interfaces. Interfaces in Objective-C are called protocols. Here's a protocol for printing. In our printing protocol, we have at protocol printing, and we have void print. So we have one method that we're sticking in the printing protocol. We're calling it print. Then we have this interface printing. Interface printing that's going to extend NS object. So the interface would define anything else that we're going to implement in objects as well. But the rule for the protocol is called print. So the protocol or the interface, not to be confused with other interfaces in this file, defines single method print. So we're going to implement this protocol 2 ways, one with a fraction and one with a complex number.
What's the difference with that interface and protocol?
We can have optional and we can have mandatory implementations in our interface. If we make it optional, we stick it in here. When we make it mandatory, we stick it in here.
In Java, it's all mandatory, right?
In Java, it's 100% mandatory. In Objective-C, we have choices. We can actually add to the interface, and if we do, we put it in here. If we include this .h file into other .ms, it's just like putting it in that other interface, but we're sticking it here to centralize it to make it so it's part of this protocol. Kind of weird. Most people would leave this out, and you can leave this out and just put the protocol in here. But just know you can actually add an interface in here too. These are optional. That's mandatory. So I'm going to remove my testing one, but if I look at my testing one, I see I just have the protocol in here. And the protocol follows object. So if I compare this one with this one, we took out the NS object, we put the NS object down here, and we just declared the protocol here. Two different formats, doesn't really matter which one we use. Actually, what we ended up doing, I think, is I may have used the wrong protocol. So if I come back up here to File, New, let me just take another look here. I used an iOS protocol in an OS X application. So if I go here and I click on protocol and make another protocol here, I'm going to call this one test 2 a second. I get the same, okay, so I get the same format. You don't need to put this on here. It's optional, actually. It depends on what you're going to do with it. So I'm going to remove this one here just so I don't have any confusion. Remove and move to trash. And then I'm also going to move this one here called testing, because we have one called printing that we're going to use. So the printing protocol, if I look at fraction.h, I import printing.h. So I have my printing protocol in here. This is how I'm using the protocol. So in Java, we say that, class, my class, extends another class and implements this interface, comma, that interface, comma, that interface, and that one over there. In C++, we say interface fraction colon, aka extends NS object, and instead of using the word implements, we don't have implements, we have these opening and closing brackets here to say that this is a protocol. We put a comma in here and we put another protocol in here. And we put a comma and we put another protocol and a comma, another protocol. We can implement multiple protocols or multiple interfaces. We extend only one class. So just like Java, we have a single line inheritance. Single line inheritance because only one class is inherited from another class, with multiple protocols or interfaces, which gives us multiple functionality, but it's still a single line inheritance. C++ is multiple inheritance. No protocol, no interface, nothing. Just everything is inheritance, but it's multiple inheritance. So people say that multiple inheritance, they criticize C++ and say, well, that leads to problems. Yeah, you can inherit a dog from a pigeon and a car. And you'll be like, what happened with that dog? It's half pigeon, half car. Like, that's really weird. And you can actually make, it's an unsafe language. You can make so many mistakes with it, and the language will allow you to do it. So this follows more of the Java routes. Okay, so if we're going to implement the protocol, let's just take a look at fraction. So we have fraction.h, and we're going to import printing.h, which is our protocol. And we have at interface fraction NS object, and we're going to put it right here. Here's our printing. It implements the printing protocol. We have our properties for our numerator and for our denominator. And then we're going to return a fraction, and here's our initializer. It's init with numerator int and denominator d. Nothing too advanced. We don't have to put anything in for this. We've already included it. So in the .m file for fraction, here's print. This is the method that came out of our protocol, aka an interface. So if I take print out, let's just take print out of here for a second and get rid of all of the format. So it's not a formatting error we're looking at. And then I come over here and I put my mouse over here. It says the method print in protocol is not implemented. Reminds me of the messages you get out of Eclipse with Java that says you've got an interface that doesn't have, would you like to implement them now? And you click a button and it implements them for you. So it tells you, which is a warning, but if I run it, build succeeded, but I still have a problem with it. It's still going to come out and collapse on me. So not such a good idea. You need to implement that. It should have gave me an error, not a warning. So that brings up another point.
It's mandatory.
It is mandatory.
It didn't throw any.
It did, but it didn't throw me an error. It threw me a warning. which is the next point I'm going to make. Usually what we expect out of a compiler is an error. An error is an error. But an error is generally in a category that's different from a warning. In Objective-C and in Xcode, there's a lot of errors that aren't errors, or not red, they're yellow, because it's logic and not syntax, but the program still doesn't run. In my theory, I say, well, if it's not going to make the program run, then it's an error. So this is technically, it's yellow, so it's technically not an error, but it's violating categories. This program won't run. It says build succeeded just fine, right? But do you see any nice printed output on the bottom of the screen? Now I see unrecognized selector sent to instance, yada yada, terminated out due to uncaught exception, yada yada. It doesn't look too good to me. But the program itself, in fact, that's kind of similar to a problem you were just working with earlier. You got an error in here somewhere, but the compiler's not telling you there's an error. Instead, it's giving you this lovely little warning thing, and you're looking at this stuff going, well, what's wrong with this thing? It's not working. So be cautious and be aware of warnings, because warnings are errors. They're not masked as errors. They don't look like errors, but they are errors. But they, red is a terrible sign. Yellow is even worse, because I'd rather have it be red. I'd rather have it tell me that I need to implement that protocol, which is what the problem is right now. If it told me that, then I wouldn't be trying to run it, trying to figure out what was going on. We just actually had that experience earlier with her app that she was running from the previous example. Nothing red, it was all yellow, should work. But there's something wrong with it, but it's not going to tell me what's wrong with it. I'd rather just tell me what's wrong with it, that way I can fix it. But in my case, I already know what's wrong with it because I did it on purpose. So I'm going to put this back. And if I put the unimplemented method back that was part of the protocol, and now I run it, I'm going to get a beautifully running program like that, and it's going to work. But a few minutes ago it didn't work, but I didn't get any red messages. See, now I got nothing. No issues. So be cautious. If you see the yellow stuff, fix the yellow stuff, because it's not, your program's not going to run. They should have just made it red, really. All right, so what do we got here? In fractions.m, we got the old style of the synthesize going on, but don't worry about that. You've seen initializers all day today, just another one looking at right here. And then here's the method. The method's going to do a printf because, I don't know, we didn't want to do an nslog, so we did a printf on it. And the printf is going to print out the self.numerator and the self.denominator. All right, so we have another one over here called complex. Complex is also using the protocol. And complex here is coming from NSObject, and it's implementing the protocol. So we have the same syntax here. And in the complex, we have a real and an imaginary, and then we have an initializer that's going to set our real and our imaginary number. So in the .m, we have yet another method down here called print. That's going to print out our real and our imaginary number. So we have two different implementations of the same method, print. We're required to use print in here. We're required to implement it. We can actually leave this blank if we wanted to. I mean, we can leave the body, but we have to actually make the method body. Everything you know about interfaces, call it a protocol and you understand the entire concept. We can't put instance data in there. We only put method prototypes in there. In Java, we could put class level data in there. You're never going to see that in a protocol. Because why would you have class level data when it belongs to a class? When it's going to belong to an instance of a class. Why would you put data in a protocol? But sometimes you need the data if you're going to have something that, I don't know, is going to be needed, that you're going to need in terms of its variables. So there's another interesting part of this, and it's going to be in main here. If I take a look at main, I'm going to see some interesting programming going on here. So what do I got? I do not have to include the protocol anymore. Just like with interfaces in base classes, once it's incorporated into the class, you don't have to keep continuing to import or to continue to implement protocols that are already implemented. They become part of the class. So here we just included fraction.h and complex.h. And in doing so in our main program, we're going to make two objects here. We are making a fraction, and the fraction is a pointer called fract, and it's a fraction alloc, and it has an initializer that's going to run here with our numerator and denominator. That's stuff we've seen all day. And then we have complex, and that's going to be a complex alloc with a real and an imaginary. Seen that all day as well. Haven't seen this yet till right now. So we're going to tag a local variable, a local reference, object reference. We're going to call it printable. We're going to implement the printing protocol. Something totally different. We don't see this in Java. We don't see this in C++ because we don't have interfaces, but Java would be the language that uses interfaces. Can't tag like that. So we tagged an ID to say that it's a printing. It abides by the printing, which means we have printing in there. So we made the ID abide by it. So first declaration of the object, which implements the interface, and a variable ID that implements the interface. These guys implement the interface. This one implements the interface because we have printing in here. And the reason the object is of type ID is so that we can implement multiple interfaces with that. So we can switch it around. ID is the reserved word, meaning that it's an object. Any object can go to it. Then to switch the implementation, we just change the implementations around. So let's take a look at why we did this. So objects can equal other objects of the same object category, or same object type. So printable and fraction have something in common because they both implement the printing interface, which makes them compatible. So we imprint objects with protocols that make them compatible with other objects, which works. We can't do this in Java either. We can use an is-a relationship in Java, but the reference type is still of the object hierarchy. Here we change the hierarchy to include the interfaces. So now, if I said printable, which is an ID data type that implements this printing protocol, I can say that printable is equal to fraction, but fraction is a fraction. And then over here I can say printable equals complex, but complex is a complex number. If I come up here to complex, I see the complex comes from NS object. And I see that fraction, well, fraction also comes from NS object. The two of them have nothing in common with each other. But ID is in common with them with printing, and both of them belong to printing. They both of them implement printing. So now I just found common ground between two hierarchies of different family trees. Two separate object inheritance lines are now brought together by a protocol. So now they're both compatible. I can move them back and forth and treat them all the same. So now I said printable is equal to fraction. Printable the fraction is, and then run printable print. Because printable was equal to a fraction, and the fraction is an alloc of a fraction, this printable is going to be giving me the print method out of fraction. And then this one down here is going to give me the printable print from a complex number. I'm going to get two different print methods because although we're referencing them with this printing, they both have print, which means they could both do this. But they both have two different implementations, and it's whatever we created them as to who they really are. But they're both compatible with ID. So if we run it, we see that fraction is 3/10, and that the complex number is this one here plus this one here, whatever the complex number is. So it's basically noting that we have two separate outputs that came out of here, but they're both being referenced as an ID printable.
So we can do that without the ID as well, just fraction.
Yeah. Oh yeah. If you wanted to, good question. You can do this. It's still a fraction, and fraction has it, so you could go like this, print. And for the same reason why you can also do this, complex number, print. That works too. This is just showing you that the ID also implements it. So because it's in there, the method hasn't been overridden in ID. We could overwrite it, actually. If we put it in a higher level object, then it would load whatever it is that, however the object is being created and referenced is going to give us our runtime interpretation of it, because it's all determined dynamically. Questions about protocols. That's all you have to do with a protocol. So a protocol only gives you a .h, and it's just like an interface. Only method prototypes go in it, and you implement the method prototypes in the .m files of the class objects that are implementing the protocols. So that works out great, theoretically. So I shouldn't say theoretically. Did it work? It's, you know, there's people that like protocols. There's people that don't. There's people that love interfaces. See, in Java, you get to switch between an abstract class or an interface because they're both the same thing, really. In Objective-C, have you seen abstract classes yet? No.
Maybe the protocols.
No. The abstract, well, the thing is we don't have to delay. If we have, okay, so abstract is interesting. In C++, they put out, this is a slight tangent on this protocol concept, but let's compare this with abstract classes for a second. And C++, actually, or Java, well, C++ is probably a better one. They made things, there's no such thing as an abstract class, but if you have an abstract method in a class, it becomes an abstract class. The compiler won't let you make an instance of it. In Java, you actually call it an abstract class, and the same kind of rules apply to it. But in C++, the reason why you're using virtual and abstract is because you don't want the wrong implementation of it, because it's statically allocated, statically assigned, statically determined. It's a static language. If you make it all dynamic, you're never going to get the wrong one. So what do you need it to be abstract for? You put it in the interface, but you don't implement it till you're going to use it. So you can have stuff hanging around. You're not calling it. There's no keyword abstract. There's no keyword virtual. But the concept is still implemented in the language because you're not going to use it till you implement it. You don't implement till you're going to use it. Why carry it through the entire hierarchy if you're not going to use it? So the logic is kind of weird. I mean, why carry it from the beginning? When you need it now, just use it now. So if everything is dynamic, like Objective-C is completely dynamic, we're not going to have any problem with any statically created implementation of some method that doesn't belong with our current object because it was created five steps down in our hierarchy. There's no need to make it abstract to delay it. What virtual does, in C++, virtual makes it compatible with the same way Objective-C does everything dynamically. Virtual makes it so it's a dynamic allocation until the object actually is created and referenced. The method's not created. Just delays it. Pure virtual methods are like, you know, the abstract version of it because it's not implemented. So in Objective-C, we have that done for us automatically. So there's no need to call anything virtual. There's no need to even define it till we're going to use it. When we use it, we use it. If the object isn't being referenced, and we saw this earlier, if the object's being referenced as a square, we get the square. If it's a rectangle but it's really a square, whatever it is, we're going to use that one. So we can change its context, change its referencing environment, move it around all over the place. Everything happens dynamically. We can convert it, cast it to different object types, and get whatever method is associated with it. So it's a little safer, so we don't have to play all those tricks. We don't have to like keep carrying an implementation all the way down the road. So Java does this whole abstract interface thing because it's limited. Because if you make it an abstract class, you can't inherit from it. So you take it from an abstract class, you turn it into an interface, and we can still use it. We can still create multiple inheritance out of this because we want to do multiple inheritance. But if you think about the concept of object orientation and how that's supposed to work, we shouldn't have multiple inheritance. We should have single line inheritance with protocols or interfaces, or the ability to extend and to manipulate the object. But isn't it really one object coming from another object coming from another object if we're going to build a solid hierarchy? Because when we start mixing in unliked object, and we have that flexibility of inheriting from multiple different objects like we do in C++. And then we could create a dog that's a bird and a plane. And we go, what in the world is that? And the logic can be totally messed up completely. If we think about the logical order of things, we can evolve our objects and then put our objects into categories. So like we have a bird and we have a dog. Actually, I really shouldn't bring up zoo animals because I don't know anything, but what are mammals? Mammals are, we have categories of mammals that have like subcategories of different types of animals that are mammals. We have different kind of birds. We have different types of mammals. So we can make them all mammals, but they're all coming from different hierarchies in the mammal lines. They're all mammals, which means they can all abide by the same protocol or interface. But each one of them is being inherited from a separate line in the evolution of things. And we can keep everything separated, but also bring it all together using the interfaces or the protocols. C++, I don't know why they didn't have the interface concept in there or protocols. Why you just can inherit from multiple objects. I guess it makes it simpler, but it also makes it less reliable. Huh?
It allowed multiple inheritance.
Yeah.
That was the problem which led to creation of interfaces.
Yeah.
And prevent.
But Smalltalk had interfaces. So I guess I buy that logic to begin with. That because of the problems that's why Java. I'm pretty much sure that's why Java went the interface route. Got rid of multiple inheritance, went single line inheritance with abstract classes and interfaces. Because I have to give them credit, that's actually pretty good. If I'm not doing any inheritance, I can just do abstract, 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 and then at a certain point, I'm going to start implementing. My question is, why do I want to go abstract that far?
Depends on the application.
Yeah. No, it does. It's a different type of thinking. That's why someone would use Java versus Objective-C versus C++. Because then they can express themselves differently, I guess, in each one of them. But anyway, that's my spiel on protocols with a slight tangent on the philosophy of multiple versus single line inheritance. But we'll leave that one. You can ponder that one and Google it. I'm pretty sure someone on YouTube will argue with me indefinitely about how I'm wrong about something regarding the philosophy behind the language, but let them argue that it's fine. That's why we live in America, so we can argue back and forth. There's people that argue about the weirdest things, and it's pretty entertaining, actually. All right, the last set of examples for this weekend, as we're waiting for the attendance people to show up, is programming practice number 4. Programming practice number 4. You're going to love this one. I'm going to show you the category one out of here because it's, again, another example, but it's not iOS. This one is all Mac. And it's all command line stuff, by the way. So we have projects that are separated out by what they are. So here we have variables and properties. So in the variables and properties project, we have the car that has properties and it has variables. And so it's reiterating, and then we have a .m and a .h. Oh, cat, excuse me, a cat in here. Car, cat. Name, it's getting towards the end of the day. We have a name and we have an age of a cat, I guess. And then we have a print name implementation of the cat. And then we have a main program. Oh, Fuzzy. Oh, God. Our cat's name is Fuzzy. And Fuzzy's got a name and an age. And then we got a print name. So this is very much a C++ style of programming. But it's Objective-C. And it's mixing and matching parameters with properties. So use this one as an example or a way of refreshing and basically helping you understand the differences between the variables and properties. There's also one here on IDs, and if you open up the ID project, it's very similar to the protocol one we just did. In fact, it is protocol one. It's looking at fractions, complex numbers, but there's no protocol in here. It's protocol-less. Instead, it's looking at the main function, and the main function is going to create ID number, and number is going to be equal to fraction, number is going to be equal to complex number. So it's the protocol example minus the protocol, and so it gives us you know, the ability to kind of dissect out what ID means and how to use ID in the context of the program. I believe the protocol one is in here. Nope, it's not in here. We have one called private. These are all examples to show you different things. Private has a interface with a public method in it. So it's NSObject myClass inherits from NSObject, excuse me, interface myClass from NSObject. I have a public method in here, and then I have the .m implementation. So in the .h I have the public interface, which is in the .h file, and then in the .m file I have an implementation in here, and the implementation is for the public method. And then before, I mentioned it earlier on when we started building those iOS apps, I said every time we go over to the .m of view controller, I see this at interface and at end at the top of that view controller. And I say, well, that's where you're going to put your private methods. So this one is an example of that. So it's another at interface at end, but it's in the .m file, not in the .h file. Why do you want to do that? That's the only way you're going to be able to create something that's private. So I got my private method here, then I got my private method in my implementation. And most people look at this and they go, well, wait a minute now. What you do here, you got two implementations and you got an interface that's all in the .m file. How can that be? And I just realized my mic wasn't working. So the people in the back are talking, so it's really hard to hear people. So we have this private. We can actually leave that out and it's still private. So, well, it's still not working. You know what? I think it's actually dead. I think it's running. Oh, there it is. Now it's working. I think it's running out of batteries or something. Nope, it just went dead again. My dog collar's not working. That means it can't laser tag me if I start leaving the building. They're supposed to keep you inside the building. Anyway, that kind of means I can pull the sucker off. Anyway, so I'll try to talk louder here. We have the keyword private. Private's telling us that this method is private. It's a strong cast. We can leave it out, and we can actually put the interface and the implementation all into one file, which is what you're looking at here. And we changed it by putting private on here. It changes the access method. Is this standard? No. Can you do it? Yeah, sure, why not? Is there anything wrong with this? No, not really. It's just going to essentially give us some more flexibility. It's a way of breaking the rules. We have a lot of flexibility and a lot of freedom with Objective-C, actually.
So when you make it private, the child case cannot use this method.
Private means that it's only accessible inside of the implementation, and that it's not accessible outside from main. We can't run that method. So we can't run this private method outside. And we can't run it from classes that are inherited from this class. The same rules apply with C++. Public is accessible from inheritance. It's also accessible from main. Private's closed off from inheritance and closed off from main. Protected, we also have protected. Used in inheritance, also used in main. Excuse me, not used in main. So main is blocked off, but inherited classes can still use it because it's protected, not private. Why do you want to do that? I don't know. Because you want to hide something. That's why when we open up all those view controllers and I always take out this, just remove the interface at the top of that file because I'm not going to make it private. Why am I going to make it private? But I guess if I had something that was only going to make sense by the class object and it wasn't going to be used outside of that class object, then maybe I would. So out here in main, I have a simple object that's being created. And this one completes, but if I try to do this one here, it's going to throw an exception. Because it's a private method, I can't run it from main. So this is going to cause an exception to throw. Why did I do that? Because just to demonstrate that it's private, it's not public. But if I had to, I could use this, and the reason why I'd want to do this is because I'd have some method inside of the class that I was going to use inside of the class that I don't want to be used by main, but I want to use it in the class implementation. Did you see the attendance person? No?
Yeah, she's done with the next class.
Okay, we're almost there. Class. We have an example called class. What's class going to do for us? Class is just a class A. Class A has got class level members in it. So this weekend we've been making a lot of instances of objects, and we've been making a lot of objects that were going to be used as instances. This one's a class. So we have interface class A. What does it look like? Person, it looks like employee, it looks like all the other classes we made, but instead now we have the plus symbol instead of the minus symbol next to the methods. So these are method prototypes. In the .m implementation of this, I see it implemented. So I see that I have integer count and initialize, and this int initializer created. So out in main, I can run these class methods. So I do class A, integer count. Class A, integer count. So the only thing difference is I'm not running the methods on instances of the object, I'm running them from the class. Equivalent to the Java keyword static. And, well, actually this is C++ static as well. It's a class level instead of an instance level. So I run integer count. Integer count is this guy here, along with initialize, it's another one here. Out in main, class A, the name of the class, and then the method I'm running from the class. And so I have instances created. I have C1 and I have C2. Alloc is a class method. Init is a class method as well. If we could keep the volume down, I can't. Yeah, my mic lost its power, and I'm challenged now at the end of the day here. Just take it outside. When the test person comes in, you can come back in. They don't even hear if I'm even looking at them or stop talking. Just take your conversations outside. That way I can speak, without having to yell. Okay. All right. The attendance. Oh, now it's real quiet. Now the attendance person will show up. All right. So we have. We're printing it out, and we're printing out by the class level. So it just gives you a better understanding of class versus instance methods. Not a bad idea to know about all of this stuff because that's what you're going to see on the final exam. Usually I say that, and then all of a sudden it gets quieter. Constructors, also in there. The constructor in here is our convenience constructors. So we have in here initialize with numerator, denominator. Nothing really too fancy. This is just an initializer. And we have the initializer in here. And all we're really going to do is run the initializer. So here's our initializer. We're going to do a fraction init, a fraction 2 with an init, and here's one with an init with both of them. So
that init is a class.
Init is our constructor.
So init is a constructor, but you said in the previous one it's
Init is a class method, and we run it on the class object.
So if you go into the fraction class, then the class method should be plus.
That's the weirdest thing. We make it part of the instance because when we return the object, we're running it on the object. It's the most bizarre thing. If we look at this, the way that this call is run, alloc is a class method. We're running alloc on fraction. We can also make the initializer a class method and run it on fraction, but we're not. We're running it on self that gets returned from alloc on fraction. Because this is inside, so we could stick f fraction 3 in here instead and do this in 2 separate calls and initialize it separately. Or if we wanted to, we can initialize it with the fraction. We can make it a class. So the other example had it, initializer. Oh, good. I'll end at this example then. The last example had this as a class. This one has it as an instance. So this is this one's defined because of the minus sign. This initializer is part of the instance creation. So I don't know if I answered your question or not.
So it's okay to have plus and minus, doesn't matter.
Correct. Correct. On the initializer, you can have the initializer be class level or instance level. You're just going to run it on a fraction, or you're going to run it on a reference that's created by a fraction. This one is after the fact. This is a class that got allocated. And this is initializer that's running on the class. Since all you guys are going to take off as soon as yeah? I know. Thank you. Since all you guys are going to take off, I'll end with this lecture because I know you're all going to leave. So this will be the last lecture. What I'll do next time is start with this example. So if you want to, actually what you should do is go through code 1, code 2, and code 3. We only got about halfway through code 3. Go over the example, see if you can do assignment number 1, 2, and 3. Assignment number 3 is all the inheritance stuff. If you can get through the first 2 by the next class meeting, you're in excellent shape. And then you can upload it. Otherwise, it's all due at the end of the time, and then I'll see you the next time. When are we going to meet next time, actually?
9th.
November something?
November 9th and 10th.
Hey, another month from now? I'll see you in a month. Wait for the attendance, and then you guys can all go. All right.